I am the founder and CEO of a company called BlockScience. I launched the company after leaving my job as the director of data science for a media company, which I actually only did because I didn't know what to do with my background in basically control and optimization of multi-agent systems and basically lots of math-heavy engineering stuff, which wasn't that useful. So I went to data science, where everybody goes who knows lots of mathematical and numerical programming. In any case, I've been fortunate enough to be a contributing advisor to actually nearly a half dozen different crypto projects to date. And I'm going to talk a little bit about what differentiates the projects that are being built on Decentralized Toolkit. So our goal today is going to be to discuss best practices for creating applications enabled by decentralized technology. So one thing about this definition is it doesn't say dApps, because I'm actually talking about more than just purely decentralized applications, but actually what it means to build an application that is sort of has decentralized parts. And we will work from there to what it means to do an ICO, because an ICO is actually defined over something that you've created. So if you don't talk about what it is that you're creating, then you're probably not doing the right thing if you're launching an ICO. So we're going to start with blockchain. We won't go into a ton of detail. We had a great history and overview lesson earlier from Sloan. But I want to talk about it from the perspective of the technology as a decentralized ledger. So what is actually going on is that we have a network of nodes that are agreeing. We have talked a lot about the ledger in terms of the sort of record of funds and the role of money, but as a piece of technology, what we actually have is a thing designed for consensus. We talked a little bit about proof of stake and proof of work, which were modes of sort of agreeing in the context of cryptographic networks. But in our case, we just care that there is such a method. So we have a data structure. In the case of Bitcoin, it's a ledger. In the case of Ethereum, it's the state of a virtual machine. Nisa mentioned the virtual machine earlier. But for now, this is what I want you to remember. We have a data structure. Then we have a set of methods that help you say that you want to change it. And then we have a set of protocols that help everyone agree that the changes that you made were acceptable. And now we have the community, the nodes, the participants, basically the network that actually asserts that, in fact, we agree and this is the valid state of the network. And so from the perspective of everything that we would build in the blockchain community, in the crypto community, we should remember that at the heart of it is a community, and that the community's job is to agree on things. And after that, we can build all sorts of stuff based on the idea that we have tools for agreeing. So I'm going to move a little bit more quickly through some of the material since I know it's getting late, but a lot of people, we talk about protocols in the blockchain space. These are essentially lower level communication tools. A communication protocol in the general sense could be something like HTTP, and in the more general sense, we just think about it as how we tell one system a piece of information in another system. Consensus protocols are basically using communication protocols for a large number of members in a community or in a network to come to an agreement about some piece of information. In our blockchain example, that was our data structure, whatever it was. An interesting thing about consensus protocols is they're not actually new to crypto. You can find examples of consensus protocols from the control of platoons of robots to models of behavior in actual biological behaviors. So think starlings, flocking, other types of birds. They can be used to model schools of fish and are actually really useful tools for understanding the heuristic behaviors of animals. They can be used to control networks of robots. They're general purpose tools for solving problems involving communication, agreement, alignment, and, well, generally speaking, systems involving parties that are working together to accomplish any goal. So I'm not going to dive into the details, but this is an example of an individual transaction on the right based on the Ethereum white paper, and this is a sort of a stylized view of a blockchain in the sense of using, well, you know what, it's probably not the time or the place to go into it, but we have this idea of a Merkle tree, and we can go into definitions of how the cryptographic security leads to global agreement in the absence of explicitly knowing the other parties in the network. But the key here is that through this technology, which is based on private key and public key encryption, we are able to assert that a chain of events has been unperturbed, that no one has gone back and modified it. So we can agree globally. So now that we've decided that this technology is a means of agreeing and thus potentially coordinating within a community or within a network, we're going to talk about what that means for applications. So is there a way to get this to stay? Oh, okay. Great. So right now, we kind of have two means of coordination. One is we coordinate with each other directly. That is through peer-to-peer coordination. We do it every day when we go talk to our friends and we say, hey, let's go grab a bite to eat at this place. It's also, common in computer systems. The Tor network is a peer-to-peer system. And then we have applications that help us coordinate. There's some central authority. We can give some examples. There are all sorts of coordination authorities. The gig economy is full of, we have Airbnb, Uber and Lyft, TaskRabbit. Even some older coordination mechanisms sort of have the same two-sided market feel. Even credit cards, right? You have merchants and you have customers. Well, the credit card is neither of them. They're simply facilitating the coordination of two different types of parties. Rather than sort of go into great detail, I would say we kind of understand that anytime that we have two parties that don't really know each other transacting, someone fulfills a coordination facilitation role, and often with the blockchain space, we talk about disintermediating these roles. Well, the role doesn't actually go away. You still have a need to facilitate coordination between the parties, and the blockchain technology is a tool that allows us to do that more directly. So, in the context of decentralized coordination, right now, most of what's been matured in the space is what I call protocol level. This means that it's a tool for building things more than it is a thing in itself. People talk a lot about where's the killer app for blockchain, et cetera. Well, the reality is nobody built it yet. And part of the reason nobody built it yet is because we've been busy building the things that we're going to use to build those things. And so this is part of the reason why I think it's so important to have this event, is to talk a little bit about what the things that we've built that can be used to build the killer app. And I want to point out BitTorrent on here because there's no token in BitTorrent. So you don't actually need tokens to have decentralized coordination. Certainly they're tools and they can help you align incentives, and they're used as stores of value, of means of transmitting value. And the Ethereum network, as we talked about earlier, you actually use the Ethereum to pay gas fees. Gas fees represent the computation, the paying for the computation being done by the other participants in the community, the other nodes in the network. And one thing to note is that we've started to see the rise of systems that are made up of other systems. So we have projects like Civic and Uport, which provide self-sovereign identity services. These are still kind of tools for building other things, because we're not saying that identity is a killer app, but I'm pretty sure that whatever the killer app is probably going to have a role for an identity subsystem, like, hey, this is me, therefore I can do this. We don't have many applications in the real world where one of the features is nobody knows who I am. I know that we talk about that anonymity and pseudo-anonymity in the context of blockchain quite frequently, but in reality, as we move towards applications for people, as opposed to the niche community that spawned some of these technologies, actually being able to prove who you are is a feature. And it's one that you would use in order to participate in the actual economy. And then another example is IPFS, which is a decentralized file storage layer. And this project aims to basically be a protocol in place of like HTTP, where you would go look something up and it wouldn't be hosted on some central server somewhere. It would be hosted on this decentralized network where you're essentially sharing your capacity to store files. Again, though, file storage is an important subsystem which was built on top of the sort of advances in the decentralized ledger technology. But ultimately, it's not the end app. It's something you use to build another app. So what are blockchain applications, sort of what's the state today? Well, probably the most famous thing that we've had recently was CryptoKitties. It's kind of silly. It's a little bit like Beanie Babies on the internet, but the reality here is that the application was more of a stress test on Ethereum than anything else, because it got launched. It had a soft start. It was open beta. People got on, played with it. It was exciting, started talking about it. And then it got opened sort of publicly, and a lot more people got on it. And it turns out that Ethereum is just one virtual machine shared by everyone who's using it. So when lots of people started using it to play CryptoKitties, it didn't really keep up. And so the user experience went way downhill. So my mom was playing with this toy. This is a short sidebar. I gave my mom $40 worth of Ethereum, and she started buying cats during the beta. By the time the network was no longer working, she had over 120 cats, and she had made over $3,000 in Ethereum. I took the money out, and I bought her a MacBook for Christmas. In any case, the point I'm trying to make, though, is actually my mom stopped using it because it was so bogged down. Transactions were failing. She was using her Kitty Ethereum wallet in MetaMask that I had helped her set up. But the reason she stopped using it wasn't because she wasn't having fun playing the game. It's because the game wasn't working anymore. There were too many cats there for her to find which ones were actually actively, being used. There was long wait times, and the actual effective price of the cats was getting actually insane. Like, she would pay, part of the reason she could make so much money was because of how much they cost. But at the same time, she had this, weird feeling when she spent $40 on a digital picture of a cute cat. So I bring this up because I would say this is sort of to date, the culmination of a user-focused application, and in some ways it proved to us more about what needs to be done than what the current state is, and I think it's an important launch point. And I'm going to jump over to something that's non-Ethereum-based, just to make the point that you don't have to build applications on the Ethereum ecosystem. LBRY, or LBRY, is a fork of the Bitcoin core, and it is augmented with a DHT, a distributed hash table, and it's a marketplace for buying and selling media. Ostensibly, the goal is you make your own content. Instead of putting it on YouTube, you come host it here, you set a price, or you can set it for free, and you're essentially incentivizing good behaviors in the DHT, which is the core tech behind the BitTorrent network, and essentially nodes are paying each other to carry the blobs that make up these files, and when you go to buy one, I pay the owner, and some small dust amounts are paid to the host nodes, and essentially we have delivered content from a decentralized network, and yet the information about the original publisher and the payment to the original publisher is still routed to the correct party. It's pretty cool. Some friends of mine have been working on this. I contributed some a couple years ago. This slide I made in 2016 actually shows you what a breakdown of an application might actually be. We have the protocol level down at the bottom, which is actually the decentralized networks. This is where transactions occur, data is stored, any other functionality that's these lower level services would reside. And then you get to these middle actual quote unquote service layer, and this is often actually centralized services. It turns out a modern application almost always has things like machine learning microservices or some sort of intermediate layer centralized service, a search function, a set of microservices of any kind that actually represent part of the back end of your application for which it is simply not currently feasible to decentralize it, nor is it necessary. Because the protocol layer is where our community resides and the participants actually act through their own software agents, and those software agents are controlled through your DApp or the endpoint the users interact at. But you don't strictly have to think of the solution as being purely decentralized, because that's part of what puts us in the CryptoKitties conundrum. Because everything was decentralized, there was no trade-off between sort of what parts of the functionality could be centralized and thus provide efficiencies, while other parts were decentralized to bring you the benefits of sort of being a unique actor within a greater community and having the coordination layer. So I'm going to tell you a little bit about, okay, we don't have the text. All right, well, I'll tell you about this anyway. So this is the most technical diagram that I'm gonna share, and the idea is that we have this front-end user interface, and anyone of any role within this network can participate through that layer. And then our back end is going to be made up of some centralized services, depending on what you need, and then a bunch of networks, which may or may not be on the same network, but they can be decentralized use cases with specific services to fulfill them. So in this drawing, the two in the middle are supposed to be your core functionality for whatever your app is, and then the one below it is the role of identity. So we would often have the expectation that there's an identity network. We would encourage using a self-sovereign identity platform, something where you actually control your identity rather than a third party. It is one of the use cases that these lower level systems are reaching. The lower left would be sort of private data, which you would access through proving your self-sovereign identity. So if I have information that needs to be available to this application, but I don't want it in the centralized servers, but I might need it to actually work within the context of this application, I could store it in, say, IPFS with a signature from another network asserting that this is who I am, and therefore I have the right to recover this information. My lower right-hand box is a network that supports payments. So a lot of projects we talk about have a token which is used for payment for some system, but if your goal is actually just to exchange money for something, like I provided you a service and I want to pay you, we don't actually want the price being bouncing all over the place. Technically, you could use PayPal to do this job, or you could use some payment service. Ripple and Stellar are the projects that I think in the blockchain space are most focused on payments interacting with the existing infrastructure. And then this box up here, the one that creeps out over the line, this is the actual token that is representing your application. And so we're going to move into discussing what it means to have a token that actually kind of peeks out from underneath here, because that's where the ICO comes in, the initial coin offering. So before I jump into that, I want to take a quick note. I've defined these applications not as strictly centralized or centralized. This example on the grid shows you sort of the 4 corner points. You have a purely centralized piece of software. If you have a piece of SaaS software owned by a business, they rent, you pay a license fee and you use it. The software is centralized, the business entity is centralized, nothing special. But if we look at decentralized software in a centralized business context, you recover some enterprise private networks, and it's important that our definition required a community. In this context, the different entities are often silos within a business or some basically sub-entities which for some reason previously had difficulty coordinating with each other. The problem isn't that, they're not in the same business. The problem is that they're really bad at working together. And so the benefit of bringing the technology in the lower left-hand corner is that you actually improve coordination. If we go up to the right side top, it's technically possible to have a piece of SaaS software that's completely centralized and to use a token as a means of membership. So your token is a digital abstraction of something, and one of the things that you could abstract is the right to use the software license, or you could actually abstract a gym membership or a country club membership or anything really. But right now, that's not really the way that people are using them, but it's important to understand that's one of the edge points here. And then finally, we have a fully decentralized network where this is where we would see Bitcoin. This is where we would even see something like the Tor network itself, right? There's no token involved, but it's fully decentralized. There's not unless you add on another piece of software that you use to search over the network to find things, you're actually talking about a fully decentralized network. So when we get into ICOs, we have to talk about more than just selling of the tokens. First off, the tokens have to come from somewhere. So there's this thing called a TGE, or a token generation event, and this is the event in the history of the software where the tokens came into existence. In the context of a lot of projects, these TGEs are launched and then the tokens are distributed per a sale, but if you actually are raising money before you actually generate the tokens, you have this concept of a SAFT. A SAFT is based on the SAFE paradigm, which is a sale agreement for future, equity. Sale agreement for future equity is the conventional model. The sale agreement for future tokens is the equivalent in the blockchain space, and this is actually a investment contract in the real sense of the terms. It's subject to regulations around accredited investors, but ultimately it's a tool for people to sell the future right to tokens that haven't been generated yet. So the TGE hasn't happened. An initial coin offering is actually the point at which you are selling tokens. All of this has actually relatively deep and nebulous regulation implications. I'm gonna take the moment to say that I'm definitely not offering any legal advice, and this is really just to give you some definitions. I will sort of note that some people, in an effort to avoid these concerns, use a method called an airdrop. An airdrop is when you just give away tokens. So rather than having an initial coin offering where you sell tokens into the market, you give them away. A common way to distribute them effectively would be to say give them to anyone who has tokens in a different blockchain, sort of similar to what would happen if you, say, had a fork. So in the case of the fork we discussed earlier with Bitcoin Cash, effectively it was an airdrop because when the fork happened, everyone who had Bitcoin had that much Bitcoin Cash. In a newly launched network, you could still have a model where you went and looked at a snapshot of another network and said, these are entities that are using cryptocurrencies, and we want to distribute tokens to sort of kick off the network effect and give them away according to that. You can give them away in a lot of different ways. It is important to remember that just giving things away actually still doesn't get you around concerns regarding regulations. It's still potentially a security. So I will first take a quick note about the way the timelines tend to work out today. We have teams launching white papers that really just detail their products and talk about what it is they're trying to accomplish, why they're trying to accomplish. I borrowed this from Blockchain Hub. I found it online, so it's definitely not mine, but I wanted to find something that was a simple, compressed overview of what projects do when they are launching tokens. I want to get into what it actually means to write a white paper, because there are two different kinds of white papers, one of which is really a vision statement. It's a description of your product, how you want it to be, what your overall, what you're attempting to accomplish with your application. Sometimes the focus is actually on what it will be eventually as opposed to what the MVP will be. This is really more of a product pitch. Its counterpart is a technical white paper. Technical white papers are much more common with lower level, more technical tools than with applications. They get into the details of how it works, why you can trust it. In the case of blockchain protocols, core blockchain protocols, they generally address how consensus will be reached, what the actual communication protocols are, and what the agreement protocols are. So proof of stake and proof of work are two of a actually broader class of algorithms that are used to assert who has the right to define the next block. In white papers that are addressing that protocol level, you'll see a great amount of detail, often even mathematical proofs about how those pieces work. So this is sort of an array of papers that I've worked on in one form or another. The ones on the left are more vision papers associated with products ranging from Freight to SweetBridge to Mad Network and Odom. And on the right are more technical white papers. Actually, these aren't protocol level, they're application level, but they're focused on the economics, because when we get into launching tokens, there's a lot of questions around utility versus security, which really ultimately boil down to whether or not you're selling an investment or whether you're selling a product. Interestingly, tokens, the term utility token gets thrown around all the time. It's not actually a thing. A utility token just means not a security, and we're not qualified to decide that. So this is sort of I find it sort of humorous. It's really, at the moment, the SEC regulates this, and we don't have formal definitions from them that say what is and is not a security. But within the community, you will hear this term utility token all over the place. When you hear it, substitute it with, I don't think this is a security, comma, but I'm not qualified to decide. That's really important, actually. Okay, so the definition of a security that is sort of culled from the legal definition is that it's an investment of money with it has a dependence on a common enterprise and an expectation of profits from the efforts of others. This is just what an investment is. The example on the right is from an administrative action by the SEC against a project called Munchie, which was a sort of food app, but they basically were selling tokens well before they had anything really that could be done with them. And one actually reads through this document, the SEC outlines all of the ways in which this token met those definitions, which meant that it was a security and therefore not a security. I get a kick a little bit about this whole utility tokens thing because people hold it up like a talisman and it's literally nothing. So I'm going to talk a little bit about a project that I think did the right things with respect to their ICO. This is Mad Network. Obviously, since there aren't any formal rules that you can check off that say that it's right, this isn't like if you do these things, then you're good. But Mad Network is a decentralized advertising basically suite of software. Their initial application is payment rails to facilitate and make basically payments in the ad tech ecosystem a little bit more transparent. They had a working POC for their decentralized network before they launched their ICO. They had an actual ad tech business built on centralized business software before they launched their ICO. They had a white paper outlining their vision. They had a technical white paper outlining the research and the way they intended to implement the decentralized network that facilitated payments. They didn't raise a ridiculous sum of money. They took investment from accredited investors. In short, they did a bunch of legal diligence, figured out what was in the spirit of the regulations, and largely made an effort to follow through on what is the, quote, best practices, with the understanding that there are no formal legal best practices to date, so it's mostly about starting from the spirit of the law, trying to follow it, and actually in some cases communicating with those responsible for those regulations to make sure that you are in fact attempting to act in that spirit. So that brings me to the end of my talk. I am happy to take questions. My main qualification for talking about ICOs is having been involved in the projects and not so much in the legal or regulatory aspects directly, so please don't take my opinions as legal advice.
Hi. When you actually code a smart contract and store it, when the transaction on Ethereum happens, the state of a contract is actually stored on a blockchain, right? So what I want to know is where exactly these executable code are stored on a blockchain. I mean, is it stored on some part of a blockchain, or where are these where is this code actually stored? And where is this executed? Is it on a node or on a system where actually the user is trying to access the dApp, or?
So you're asking where the smart contract code is?
Is stored, yes.
Okay. So I'm actually gonna, I really want to punt this to Sloan, but I'm not sure if he's still here. Damn him. So in the context of the Ethereum network, the smart contract code itself is executed in the virtual machine. I'm not it's stored on the blockchain. So we have I'm not a developer, so I work at the higher level. So
Sure.
Thank you for that.
Thank
so it's
you.
stored on chain. I know it's executed on chain. Yes?
How would you value one of these coins or one of the tokens out there by looking at the market cap and by looking at what they're offering? For example, I mean, how do we know Ethereum is not way overvalued right now?
Well, the short answer is that we don't know. But the thing that I will tell you is that if you're looking at tokens as if they are stocks, then you're thinking about them as financial instruments. And we're at a stage in the game that you should be still thinking about them as products for the most part. So if you believe that something is genuinely useful, and this not because of the term utility token, but just because you believe that that thing will become part of other tools, or you believe that it will get adopted in the, whether it's in a subsystem or whether it's the application itself, then that's generally the indicator that you should look for. I've largely got into the space by working on projects, so what I have is mostly a result of what I've worked on, and that's always aligned me with the idea that I would work on things that I thought provided value. And if they provided value into the ecosystem, then they had a good chance of ultimately becoming valuable with respect to that use. In a broader sense, I've actually done some research on creating tokens whose value is driven by its use, but that research has actually led to the realization that you really want the value of the token from a use perspective to be decoupled from its market price. Right now, most of what we see is highly coupled, meaning that I use the token and its price dictates what its use is. Like I want to use $50 worth of. If you can break away from solutions that are defined that way, you can actually get a more realistic alignment between value in the market and value in use. I'm not going to go into details now, but if you talk to me later, I'll route you to some white papers on that in particular.
Oh, right here.
Yeah. Yes.
Yeah, I'll use this one. So you had mentioned at the beginning of your talk about like the most kick-ass blockchain app ever, like that's coming in the, that you would envision in the future. And I'm just curious to know what you see that as.
So the most kick-ass blockchain app is going to be an application that allows many more than 2 people to coordinate concurrently. I'm not sure which one it's going to be. There are several projects currently, some of which I am contributing to, that are mixing AI and blockchain together in a way that allows you to essentially broadcast and pre-commit to things that you are willing to do, like the way one would with Airbnb's Instant Book. But now, if many people are willing to do this, and you create essentially a ledger of pre-commitments, you would be able to use a, albeit centralized application to block those commitments into shared actions. And it is my opinion that the combination of machine learning applications and blockchain databases that are filled with people's things that they commit to will allow us to coordinate in ways that we really couldn't before, because orchestrating a multi-party commitment and ensuring that everyone is both incentivized and sort of required to follow through has been outside of our technological scope. But if we look back at some of the projects, both in the blockchain space and prior to it, a lot of our technological advancements have actually facilitated coordination, including the whole sharing economy thing. The We Trust is a coordination problem also. And when we look at blockchain as a community and coordination technology, and we combine it with the other technologies that we see maturing today, I would say that there will be a multiple party, preferably much larger than 2, because that's where it gets really hard, coordination problem. But I can't say I know which project or which use case it's going to be, but I would be really shocked if it took a form other than sort of large number of parties coordinating.
That's awesome.